So we're looking at number 25 with the mass of a robot on 2 different planets. Okay? So we've got a robot on planet A. All right, so here's a robot on planet A, and here's a robot on planet B. It says they have the same radii. Okay? So if they have the same radii, if there's a difference in their gravitational force, it has to come from the difference in what? Their masses. Sure. All right. Now, in general, we know that the weight of an object on a planet, mg is the weight, right, is equal to gravitational constant times the mass of the planet times the mass of the object divided by the radius of the planet squared. Okay? And it's the radius of the planet because the gravitational force has to do with the distance between the object's centers of mass, right? So even when we're on the surface of a planet, we're removed from its center by the radius of the planet. Make sense? All right. So now the first thing we know is that the mass of the robot is 5,450 kilograms. We also know that weight, I'm going to use W for weight, okay? Weight is equal to mg. You know what? I'm not. I'm going to say mg, planet A and B, right? mga is equal to, let's see, mgb. So which one's it weigh more on? Weighs more on planet A than it does on B. So we have to add to B 3620 newtons. Everybody okay with that? It says it weighs this much more on planet A. Here's planet A, but it weighs this much more on planet A. So we have to add that to planet B for those to be equal. Everybody okay with that? All right. So now, if you take a look at this up here, we know that mg over here, mg is equal to g big M little m over r squared. Well, what's the same on each side? This is for just any object. This is its weight, and this is its weight, this is its weight. Okay? So m is the same. Does that make sense? Mm-hmm. So g, that is the gravitational force constant, g, or the acceleration, is equal to gravitational constant times the mass of the planet divided by the radius of the planet squared. And if you put in Earth data for this, the mass of Earth and the radius of Earth, what do you get for g? 9.8 meters per second squared. Okay, so now we know that this is the same robot, right? So these masses are the same, but we don't know about this. So we can't just cancel out masses. We're going to need to know the mass of the robot. That's why they give it to us. All right, so now GA, check this out, is going to be equal to, all right, so let's just rewrite this whole expression. The mass of the robot times GA, which is going to be equal to G times the mass of planet A divided by the radius of planet A squared. Right? I'm just substituting for this G expression we have right here. G big M over R squared. So G on A is equal to G. We don't need a subscript because that's the same for everything. Mass A, radius A. Okay? That is equal to the mass of the robot times G MB over RB squared, right, plus 3620 newtons. Now, of all of these, what is it we're trying to find? We're trying to find the difference between MA and MB. Does that make sense?
Yes.
All right, so now what we're going to do is, seems to me, the best thing to do would be to gather these funky terms, these funny looking ones, okay? So if we gather those terms, we get M times the quantity, M times, what can we pull out of each one? M big G, right? M big G times MA over RA squared minus MB over RB squared is equal to 3620 newtons. Everybody okay there? So right now we've got This we know, this we know, this we know, and we know that the radii are the same. Isn't that correct? All right, so these we'll just write as r squared. Okay? Because it doesn't matter. We don't need to distinguish them. So we'll rewrite this as mg over r squared is equal to ma minus mb. Hey, wait a minute. That's kind of cool because what are we looking for? Take a look at the problem. We're looking for ma minus mb. What, are you kidding me? Look how easy this is now. So ma minus mb is equal to 3620 newtons over this expression right here. So I'm just going to multiply each side. So we get r squared on the top, right? mg. So now resuming, we have r squared over mg. Now we have all the numbers that we need. Now let's take a look real quick and make sure that we are dimensionally consistent here with what we're looking for. We have newtons, which is kilogram meters per second squared. All right, that's for the newtons. For the radius, what do we have? We have meters squared, okay? So we got kilogram meters cubed per second squared on the top. On the bottom, we got kilograms. So let's just go ahead and get rid of those to start with. And then remember, G is a funny thing, isn't it? Remember, the units for G, you can look them up, is newtons meters squared per kilogram squared. Okay? So actually, oh, check that out. Let me undo this red because we could have just left this as newtons. See that this is newtons here and this is newtons here? Okay? All right, so those cancel each other out. All right, then in blue we'll cancel out meters squared on the top. So what we have is, this is weird, we have 1 over kilograms squared, which gives us 1 over kilograms. So what do we end up with? Kilograms, okay? Kilograms is what we're looking for because we're looking for mass right here, okay? So doing the dimensional analysis was more work than the whole problem itself. All right, so now all we have to do is plug and chug. We get ma minus mb. So if you guys would give me those numbers, here, I'll just copy this whole thing right here and bring it down, this right here. Hello. All right, copy that, bring it down, not up. Paste it. Paste it, there we go. Come on. Slow. There we go. All right. So what is M? We're just looking for the difference between MA and MB. Right?
Like little. Oh, yes, we do. Never mind. Sorry.
Okay, thank you. All right. Is equal to 3620 newtons times, what's the radius? Someone? 1.33 times 10 to the 7th meters, and we're squaring that, right? Divided by the mass of the robot, which is 5450 kilograms, times G, which is 6.67 times 10 to the negative 11 Newton meters squared per kilogram squared. Nice. All right, so now we plug and chug. Okay, so putting in all those numbers, and let me see, 36, 20, 13, 133, 10 to the 7th, 54. This is like 1.76 times 10 to the 24th kilograms or something like that. All right, so there's our answer. It doesn't ask what one is, what the other is. It's just the difference between them. And then you guys know QED is what you put at the end of a proof, quad erat demonstratum, that which was to be proven. Anyway, we didn't try to prove anything. We tried to solve something. Anyway, here's your answer.